All right, so we were looking at the basic object-oriented programming as supported in C#, okay? So three main things: encapsulation, creating the class, public-private declarations, right? Inheritance, deriving one class from another, virtual abstract override keywords, right? And then polymorphism. And we discussed that this further goes into overloading and overriding categories, right? Overloading is within the same class. So if we have more than one method with the same name, but with different parameters, then that's called overloading. And if we have a base and a derived class, and we inherit some function, we wanted to change the code for it, that's called overriding, right? So then we discussed that overloading, for example, can be done at the constructor level. We often provide two constructors, right? We can do it at the method level. So we can write more than one function. For example, if there was a compute AVG with 3 parameters, we can have a compute AVG with 4 parameters, right? So as long as either the number or the type of parameters is different, we can overload things as many times as we feel like it, right? The third category of overloading was operator overloading, right? So the operator overloading further goes into the arithmetic operators. So for example, we can create a class and overload the plus, minus, less than, greater than, equal to, not equal to, and so on, right? For the other category of the operator overloading was where we use these square brackets, and these are called indexers. So obviously, operator overloading only makes sense if arrays are involved. Okay. Sorry, not operator overloading. Indexers make sense when arrays or collections are involved. And the regular operator overloading makes sense if we wanted to add a new data type to the language, such as a complex data type or the currency data type, right? Okay, so anyway, I'll introduce arrays and collections in a few minutes, and then we'll further look into this. Last time we looked into the examples of operator overloading for the complex class, for the currency class, right? Anyway, to finish the topic, overriding, as you guys saw, basically involves keywords such as is, as, and reflection. Okay, and of course for overriding we have the abstract, virtual, and override keywords. So hopefully everybody understands when those are used. Okay, so is as reflection is used when a base class reference is used to point to a derived class object, right? So this is the time we need to check what's the type of the actual object we are pointing to, and we need to create another reference of the same type as the object we are pointing to before we can access any of the fields or any of the methods inside that, right? So very briefly, to refresh your memory, let's say we had a student class, okay, with let's say 5 fields. We had a grad student class where we inherited from student. And let's say we added the thesis as the extra field, so 5 fields over here. So thesis is the additional field. Okay. Now, if somebody gave us, for example, student type reference, so somebody created a code like this, student S1. However, they allocated the derived class object, so new grad student. Okay, so if through S1 they wanted to set the thesis, as we discussed, this will work, or this will generate a compiler error? Compiler error, because the way compiler works is it will check S1. S1 is of type student. It will go to the student and see is there a thesis. If there's no thesis, this will give you a compiler error, right? Okay, so what was the technique? We can either use the is operator, as operator, or reflection. So the most popular of all three is the as operator because it's the most efficient. So you will do something like this. You will say grad student, let's say GS equal to S1 as grad student. Okay, so basically as we discussed, this will go start from the S1. Okay. So if this is the memory of the computer, so somewhere in the stack area, you will see there's the S1. It will point to somewhere there will be thesis, and somewhere there will be the vtable pointer, okay, which will go to the code area. There will be a lot of pointers over here. One of them will be the type info pointer, okay, which will further goes to the type info, and in the type info there will be something class equal to, let's say, grad student, or name equal to grad student, right? So anyway, in the type info section, there will be, so this is our type info section in the code area in the memory of the computer. For every class there will be one type info, right? So what does this do? This is a runtime operation. It starts from S1, goes to the actual object. So in this case it was a grad student. Then it will go to the vtable. Then it will go to the type info and find out what is the name of the class. If it indeed is a grad student, it will create a reference of type grad student and returns in the, after it does the check, so returns a reference of type grad student if successful, correct? And what happens if it is not successful? What if it is pointing to a student, not a grad student?
Then it will return null.
Then it will return null, right? So in this example, it will return a reference to the grad student. And we can make sure GS points to the same reference. So in this example, the GS will be pointing over here, and GS already is of type grad student. However, you should not blindly assume that it will succeed. You will always write if GS not equal to null, then GS dot thesis equal to whatever you wanted to set to, right? Okay, will the compiler be okay with this statement? What type is GS? And does it have a thesis? Yes. So now through GS, somebody will be able to modify this thesis, right? Okay, so anyway, so that was the polymorphism side, the overriding side of polymorphism. And once again, this is the complication. This is the most complicated aspect of polymorphism when we use a base class reference to point to a derived class object. And we can either use the as operator or the is operator or reflection. So we already went over it. Okay, so now to finish this topic, we need to finish this part over here. We already looked at overloading, operator overloading last time, so let me explain the idea of indexers. But before we define the, before we go over the idea of indexers, we need to look at the arrays and collections, because only time we use indexer is when we have large data, meaning array, either an array is involved or a collection is involved. So what's the difference between array and a collection? Okay, so see, if we have to declare a lot of variables, int a, b, c, okay, e. So for example, if you wanted to declare 7 variables, you can either declare them like this, or you can declare them one line at a time, and so on, right? What if you wanted to declare 500 variables? Obviously, writing 500 lines or creating 500 unique names is not a good idea. So this is where we use arrays, right? And before we go to arrays, let me clarify one thing. In Java as well as C#, there's a concept of types. Okay? Types as in data types. Okay, meaning what is the data type of a variable that we declare? For example, if I declare int a, what is the data type of a? Int, right? If I say string c, what's the data type of c? String, right? So we have a concept, rather than every time calling it a data type, sometimes people just say types, okay? So types go in 2 categories. They go into what we call value types and reference types. Okay, what's the difference between value type and a reference type? Value type is always created if we need the memory for it on the stack. So that's one difference. Reference type is created on the heap. Okay, so what are the examples of a value type? Okay, the example is, for example, the basic or the primitive data types. Okay, what are the basic or primitive data types, such as int, double, float, byte, and so on. Okay, so those are the basic data types, right? Okay, what is a reference type? What's an example of a reference type? Okay, so for example, class objects. See, if we do student S1, does it give us memory for creating a student? No, it's just a reference, okay? If we want the real memory, we have to say new student, right? So where is this memory coming from? Heap. So like I said, reference types are created on the heap. So the example is like a class object, like S1 as an example, right? Okay, is there another reference type? Yes, there is another reference type. So arrays are also reference types, both in Java, both in C#, but not in C++. It could be either, okay? So that means because it's a reference type, array is a reference type, where will the memory come for creating the array? From the heap. So that means there has to be a new keyword involved, right? So how do we create an array? Okay, very easy. Okay, remember the basic philosophy in C-style languages is we first declare name of data type followed by name of variable, right? Okay, so for example, int correct? That's how we declare a variable. Okay, so now if we wanted to create an array of integers, okay, this name of the data type becomes followed by an empty square bracket, okay? So anytime you see some data type followed by empty square bracket, that means it's an array of that data type. So the way we will declare an array will be int, for example, A. Okay, but remember we said this was a reference type, right? So the memory has to come from heap. So now you will further say new int of 5 as an example. So this is the total declaration for creating an array. What does it do? It basically creates 5 variables. The first variable starts with the index of 0. Second variable, index of 1. Then 2. Then 3. And last will be index of 4. So even though we said create 5, so total there are 5 memory locations, 5 variables that created, but they range from 0 through 4. Okay, so that's what you need to remember, and same as in C, same as in Java. So all these languages are 0 index based. Okay, so anyway, this is what the memory will create. So what is this then? What is this part? See, this will come from the heap. Think of A as a reference, meaning like a pointer, which will point to over here. So this reference A will be created in the stack area. Okay, and this actual memory will come from the heap area, exactly just like when we were creating a student. Okay, so that's how easy it is to create an array. Okay, now there are a few complications with arrays. Okay, one of the complications is when we create arrays of reference types. Okay, so first of all, let me give you a statement. Creating arrays of value types is easy. Okay, so for example, what if somebody said create an array of 100 items for storing double type of data? So you can say double, and remember after the name of the variable, if you wanted an array, what will you do? Empty square brackets. Okay, so that means together this is an array, right? So now you can pick the name of the array. For example, you can say my data equal to new. And if you wanted an array of doubles, you will say double of 100, right? So how many memory locations will it give you? 100. First memory location will have an index of 0. My data of 0. And last one will have my data of 99. So that's easy, right? Okay, and then once you have created the array, you can read the data from any one of these memory locations, just like you read the data from a simple variable. So you can say, for example, int A equal to my data of 5. So whatever was stored in the my data of 5, so if, let's say in my data of 5, you had stored 23. So what will be read into the variable A? 23, right? Okay. So it's very easy to read or write the data to the array once you create the memory for it. So like I said, creating arrays of value types is easy, right? But sometimes we need to create array of reference types. For example, let's say we are creating a university application and we have 5,000 students, 2,000 graduate students, right? So obviously we need to create an array of 5,000 students, an array of 2,000 graduate students, but a class is What is a class? Is a reference type. So reference type itself is created on the heap, right? So we have now, it's like heap being used twice. One to create the memory for a class object, second time to create the memory for the array itself. So that's why you should be very careful when you create, or I should say creating arrays of reference types is tricky. Okay, same for Java, same for C#, no difference. Okay, so why do we say it's tricky? Okay, once again, because heap is involved 2 times, because heap is involved twice. Okay, so why twice? Let's clarify it again. Okay, so let's pretend you wanted to create an array of 5,000 students, right? Where will the memory for the array itself come from?
Heap.
From the heap. Where will the memory for each student come from? Class objects are also created on the heap. So that's why the heap is involved twice, and it becomes tricky. So especially if you are coming from a C type of background, this is where a lot of people get confused. Okay, so let me clarify this further. So meaning your first inclination is to write the code like this. You will say student. Again, you will put empty brackets because you wanted to create an array of students. Now you'll pick a name for the array. Let's call it ST array. You can call it anything you feel like it, right? Equal to new student 5,000. Okay, so lot of people who are new to this kind of programming will be fine with the first step. Okay, but then they think, oh, I have memory for 5,000 students. I already used the new keyword over here. Okay, so then they will try to do something like this. Student of 0 dot, let's say first name equal to Adam. So the minute they write this type of code, the compiler will be okay, will compile, and you'll think, oh, it's working. But let me finish that. Okay, but as soon as you run it, right, when the computer comes to this line, it will create a runtime error, so you will get a null reference exception. Okay, so in a minute we'll analyze why why will it go into a runtime error. Okay, because we have only used the heap once, so I'll modify that in a second. Okay, go ahead.
Student or ST array?
Oops, sorry, yeah, you're right. ST array, not a student. ST array of 0, yeah. Because the array is what we are indexing. But anyway, it will generate this error, same. I meant ST array even though I wrote a student over here, so thank you for that correction. Okay. So anyway, so let's try to figure out why this will generate a runtime error, right? Okay, so let's take a look at this statement over here, student, empty square bracket, ST array. So focus on only the left-hand side. Okay, what will this do? If this is the memory of the computer, okay, if this is the stack area, it will create a reference called ST array. So far it's pointing nowhere, okay? But once we say new student of 5,000, what will it do? It will go to the heap area, and it will create ST array of 0, ST array of 1, and ST array of 4,999. Correct? Okay, now, what type of memory is this? Okay, remember each element of this array is capable of pointing to a student. So these are references themselves. So this is a reference, this is a reference, this is a reference, and so far they are pointing nowhere, right? For example, if we wanted to create an array of students, how much memory each student needs? How many fields each student has? 5 fields. Okay, but over here we only allocate memory for pointing to a student, not the memory for the further 5 fields it needs. So that's why compiler has no problem with it, but once we try to execute this code, the computer will go to over here, and then it will try to look for a memory called first name, but there is no memory. We never allocated it. Okay, so creating an array of reference types is tricky, and like I said, because heap is involved twice, that means we have to allocate not only the memory for the array, but we also have to allocate the memory for the object inside the array. Okay, so we need to also allocate memory for object for each object in the array. Okay, so anyway, it turns out the creating array of reference types is really a 2-step process. It's not just one line of code. First, you have to create an array of reference types. Then you have to allocate memory for each object in the array. Okay, so what's the proper way to do it? Okay, so we'll write student st array equal to new student 5,000. If we wanted to allocate memory for 5,000, so this is our step 1. Okay, then we have to allocate memory for each student over here. So we will write a loop for int I equal to 0, I less than strArray.length. So in C#, every array has a length property, very similar to Java. So length tells us how many elements are in the array. So in this example, we allocated 5,000, so this will be 5,000. Okay, I++ is a shortcut for I equal to I plus 1. So the loop will start with I of 0. Every time it will increment I by 1 until I is less than length, which is 5,000. So basically this will go 5,000 times through it. First time I will be 0, then I will be 1, then I will be 2. Very last time I will be 4,999. And then it will get out of this loop, right? So now we have to allocate memory for each student. So how will we do that? All we have to do is strArray of I equal to new student. Okay, so this will end up allocating memory for each student. So this is our step 2 of the creation process for array of reference types. Okay, so what does it do now? Each time for each one of these objects, it will, in the heap area, it will create memory for first name, memory for last name, and so on. Okay, so, and then strArray of 0 will point over here. Then it will create another object, first name, memory for second student, last name, and so on. And the second one point over here, and so on. So for all 5,000, it will allocate 5 fields for each one of those array indices. Okay. After you are done with this, creating memory for each one of these, Now if you write the code, let's say stRA of 0 dot first name equal to Adam. So now it will work perfectly. Computer will start with stRA, which is this, all of these 5,000 elements. Then it will go to stRA of 0. Then it will go to the first name, and it will end up storing Adam over there, right? So stRA of 0, first name Adam, because there is a memory that we have allocated for each of the array items, right? So let me summarize the important point. Creating arrays of value types is easy. Okay, all you do is, you still have to use the heap. So simply name of the array, new, and how much memory you want. And once you have declared it, you can start using the array. But creating array of reference types is a two-step process. First, you create as many references as you wanted to store the objects. So if you wanted 5,000 students, you will create memory for 5,000 elements of the array. And these will be simply references themselves, these 5,000 references, the one in blue, okay? Then for each one of these references, you further allocate the memory for storing each field of the student. So over here, you will have, if the student has 5 fields, 5 memory locations will be allocated for each one of these 5,000 references, so that we can store the data for each student, right? And then we can use the array pretty easily. So that's the concept of arrays, right? Okay, now very similar to arrays, we also have something called collections. Okay? So let me introduce the idea of collections. Okay, so collections are similar to arrays, meaning their purpose is also to store a lot of data, okay? With one difference being a collection is more flexible. Okay, meaning it can grow in size dynamically. So that's one of the advantages of a collection. Okay. See, to give you an idea, give you an example so that you can see the flexibility. Suppose we created an array of 5 integers, right? So what will our code look like? Int followed by empty square brackets means we'll be creating an array followed by name of the array. Let's say it's capital A, and we wanted 5 memory locations, new int of 5. Okay? Then you declare some variable, let's say int index equal to 3, and then you said A of index equal to, let's say, 27. So what will the computer do in this case? Once we allocate this memory, right? Remember, there will be a reference created in the stack area, correct? How much memory we are allocating from the heap area? 5, so that's easy. A of 0, A of 1, A of 2, A of 3, and A of 4, right? Now, index equal to 3, A of 3 equal to 27, so where will we store 27? A of 3, which is over here, so this is A of 3. Okay. So anyway, it works. What will happen if somebody changed this line of code int index equal to, let's say 8. Okay, will the code compile? Remember, compiler does not check for the values. Compiler only checks. So the compiler will be okay. But what will happen once we try to run it?
Runtime execution.
A of 8, is there any memory called A of 8?
No.
So we'll get a runtime error, right? So arrays are fixed in size. Once we create them, the size is fixed. So what if you wanted really more memory later on? Unless you create another bigger array, copy the data from the existing array to the new array, you cannot do that, okay? So if the needs are dynamic, meaning we don't know as we run the program whether we will need memory for 5 things or 500 things, this is where collections are a lot easier, okay? So we'll be dealing with many collection classes, okay? Today I will introduce one popular collection. So one popular collection in the .NET library, it's very similar to Java, is called ArrayList. So this class is pre-built, okay? All you have to do is create an object of it. So how does it work? Very easy. So you will create an object of ArrayList, let's say a list. So name of the data type followed by name of the variable. And because it's a class, it's a pre-built class in the .NET library, of course all class objects have to be created using the new keyword on the heap, right? So once we have created the array, then it's very easy. All you have to do is keep adding. alist.add. So it has an add method, 5 alist.add, for example, 23, and so on. alist.add, whatever, 45. Okay, so how does a list look like? Again, let's focus over here. So here's the A list, right? Then it has, in the heap area, it has flexible memory, okay? So once we do A list.add, it creates one element over here, 5. Once we say A list.add, it creates one more memory over, right? And each one is pointing to the next, and so on. Okay, so anyway, we can just keep adding. As long as you have heap space, you can keep storing all the data in it. So it's very flexible. Okay, of course, anytime we insert, it has to create a pointer internally to the next element. So it's the price we pay for this flexibility is that it's a little bit slow, okay? But especially when you have varying memory needs, ArrayList is a very good option, okay? So here's another nice thing about ArrayList. Not only it can store value types, it can also store reference types, okay? So for example, suppose you created an ArrayList called AList, then you did something like this. Student S1 equal to new student, right? And then you set some fields over here, okay? And after you set the first name, last name, and so on, you can do alist.add S1. So you can store the student in the array list. Very similarly, if you created another student, new student, okay, you can do s2.add, alist.add s2. So you can create, you can add the second student to the list. Okay.
Don't we give type for an array list here?
Okay, here's the nice thing about the array list. Array list is very flexible. So it's extremely flexible. In fact, too flexible. Okay. You can store anything in it. Meaning, you can store a value type, you can store a reference type, you can store a student in it, you can store a number in it. So for example, in the same list later on, you can say a list.add hello, for example. You can do a list.add 23, for example. Okay. So how is it possible that we can add all these different things in the array list? Okay, and the answer is internally. Internally, an array list is an array of objects. Remember the base class object? Okay, and we also discussed that base class reference can point to any derived class object, right? So now that's the power array list uses. So everything that it stores, actually, for example, once we do S1, so if this is our A list in the memory, okay, so once we stores S1, it further puts a wrapper around or a box around it and converts it to an object. So same way as S2 is added to the array list, again a box is created around it and it converts the student into an object. Once we go to hello, to add hello, again a box is created around it, also converts it to an object. Once we try to store 23, also a box is created around it and it becomes an object. Okay. So as I mentioned, internally it's really an array of objects. So sure, it can store different things over here, right? But it does create a complication once we are trying to recover the data that we have stored in the array list. Okay, so let's take a look at how do we read the data from an array list.
Professor, question. If the array list, if the A list, when you do A list, a new array list, it creates flexible memory in the heap, right?
Correct.
And then when you do
Every time you add,
yeah.
So think of it this way, basically internally it will create a list over here. And in the heap right now there's nothing there.
Right.
Okay, so once we go to the first statement, a list.add S1.
Yeah.
Okay, so now it will change this null to S1 and convert it into an object, and then there will be another next pointer which will be null.
So it will be an object of the A list, or will be object, you say the reference?
The S1 is basically a reference. So S1 is pointing further to the student data, like the first name and so on. So it's just storing a reference in it, which is basically further pointing to the memory for a student. Okay. Anyway, so everything that we put in the array list becomes essentially an object, right? So the question is now, how do we recover the data from it? Storing is easy. All you have to do is just keep calling the add method, add method, add method. We'll keep adding, right? To recover data from an array list, you have two options. Okay. And what are these two options? Number one, index it like an array. Okay, number 2, write a loop. And the loop can be a regular for loop, or it could be what is called a for each loop. So I will introduce this for each loop to you in a second. So to give you an example, if you wrote the code like you see over here, right? I could write the code, for example, I wanted to recover the second student from here, right? So I could say, to give you an example of it, I could say student S2 recovered, S2 R equal to a list of 2. So let's take a look at the statement that I typed. Okay, what's the data type of the left-hand side? Student. What's the data type of the right-hand side? No, if it was just a list, it will be array list. It's a list of 2. What's stored in 0, 1? Sorry, let me make it 1. Let me make it 1 so that we are compatible with our example. So array list of 1. So what's stored in position 1? It's a student, right? Okay. However, remember, like I said, as soon as it goes to the array list, what does it become? Object. So what's the data type of the right side? Object. So obviously compiler will not compile it because C#, like Java, is strongly typed. The type of the left-hand side has to match the type of the right-hand side. So this will give us a compiler error, right? However, we know that in the second position, meaning index of 1, we stored a student. So if you are certain, you could do something like this. You could say student S2R equal to student. So you could typecast whatever you read from a list of 1 to a student. So if you typecast it, then type of the right side is student, type of the left side is student. Now STR will be pointing to, or S2R will be pointing to over here. And now you can read any further field. You can say S2R dot first name, or you can change it to Alex or whatever, right? And so on. So you can change or read it, anything you feel like it, right? So once again, to recover the data, you have 2 options, index like an array, but make sure then typecast it. If you don't typecast it, it will be read as an object. Okay, so let's go to the index 3 in this example, where we had put our 23 over here.
Professor, an array list can have infinite number of members, right? Maybe.
Data inside.
Yeah, infinite number of data. So while iterating, a programmer might not know what kind of data it might store. So
correct.
What can we do in that case?
Let me come to the looping in a second. First, let me clarify this part, then you can further ask the question if it's not clear. Okay. Anyway, let's go and try to read the data stored at index position 3, which we know was a number, right? So you will write some code, something like this, num equal to. Again, if you did a list of 3, will the compiler compile it? What's the data type of the left side? Int. What's the data type of the right side?
String.
Object. Okay, remember, anything that goes into the array list becomes an object. So it's an object, right? Because it's an object, if we wanted to recover the data, we have to typecast it to the same data type that we have stored over here. So you will say int over here, and then you'll be able to read it. So to summarize, once to store the data in the array list, what do? Just keep calling the add method, add method, add method. Storing is very easy. You can store numbers, you can store strings, you can store object of a class, you can store anything you feel like it. But if you wanted to recover any data stored at a particular position, you will index it like an array. Okay, for example, a list of 3 or a list of 1. But you will then typecast it to the same data type that you had stored to recover the data. Okay, what if you don't know the data that you had stored? Okay, or what will happen if by mistake you said over here a list of 2? Okay, will the compiler compile it? See, compiler does not go and check what data you had stored. For a compiler, sure, anytime you read an object, you can convert it to whatever data type you feel like it. But what are we reading from a list of 2?
String.
A string. Can string be converted to an int?
No.
No. So what will happen if you try to run this program? Runtime error will occur. It will say, I cannot convert a string to a number, right? What if you really wanted to verify that it is a number before trying to convert it? Okay. Then remember we had the is operator, as operator, reflection, so we can use those